All right, we are ready to start the last bit of Module 7. And the first thing, if you would like to do so, is you may take out the entire rest of the module, starting at Section 7.8. That is all gone. We aren't going to do any of this. We're doing it, we're just doing it a different way. The last few sections are honor sections, and clearly we're not doing those because this is an academic class, not an honors class, and we're not doing any of this. So 7.8 through the end, you may remove that entire module or that entire rest of the module if you'd like, or if you want to, just right here, and we'll say omit the remaining tasks. We're not doing any of this from this point on. I would like you to take the notes that you picked up in class on Friday and put them right here, right in front of that. So right before page 46, there it is, right before page 46, put this new set of notes in. We are going to complete this day 1 up here, pages 1, 2, and 3. Okay, again, on Friday, we took these flat diagrams and we cut them out and folded them into three-dimensional shapes. We are starting to work on surface area, so we're going to be taking these shapes basically and going backwards, taking a picture of a three-dimensional drawing, or a picture drawing of a three-dimensional figure and kind of unfolding it, if you will, in your mind and finding the area of all of the pieces. We do have some vocabulary first that we will need to deal with, and one of those words that we have to talk about is polyhedra. Polyhedra, that's plural. These are solids with flat sides called faces. The faces are polygons. So, rectangles, triangles, hexagons, squares, etc. Those faces are all polygons. And the lines where the faces intersect are called edges. So here are some of the polyhedra that you made on Friday in class. These particular ones are all the prisms. You also made pyramids. There's all the pyramids that you made. Okay. All the sides are flat sides. All of the sides are polygons. A rectangle, square, triangle, rectangle. More triangles. Oh, there's this one. That's a pentagon. And square and more triangles. Okay, a prism, which is what we're looking at, specifically a prism, is a polyhedron. There's singular. Polyhedra is plural. Polyhedron is singular. It's a polyhedron with two congruent parallel faces called bases. The lateral faces, or sides, are perpendicular to the bases, and intersect at a lateral edge. So specifically, here's a prism, two parallel faces, so that face right here, parallel to this triangular face over here. So those are the bases. That triangle is a base, and that triangle is a base. If we set it like this, the triangles here are the bases. It's not sitting on a base right now. It is sitting on a lateral face. So if we turn it so it's sitting on its base, then we're looking at this. Here's the base, base. The sides, these are the lateral faces. And those lateral faces are perpendicular to a base. Perpendicular to a base. The lateral faces intersect at a lateral edge. So this face right here, intersecting with this face right here, they meet at this lateral edge right here. Okay? Now, part of the issues with this particular unit is reading a three-dimensional figure off of a two-dimensional diagram. And this figure right here is exactly the prism we were just looking at. It's this triangular prism. Triangular prism. It's probably sitting just like that maybe, or maybe like that. Okay. The dotted lines are things that are hidden from view. Solid lines are the sections you can see. One of the things that I like to do when I do these diagrams is I like to find the bases and trace them pretty darkly with a color. If you don't have any color pencils close by, pause this video and go get some. There's the bases. Those are the congruent and parallel sides. Those are the bases. So this triangle back here, triangle ABC, is a base. And this triangle up front, triangle DEF, is a base. So those two triangles are the bases of the prism. The shape of the base tells you the name of the prism. This is a triangular prism. This part right here, that first part, tells you the shape of the base. Okay, now these rectangles here, A, B, E, D. So rectangle A, B, E, and D. That's a lateral face. That's like this face right here. This face right there, if we look at the diagram, that would be B, C, E, F. Oh, I said that backwards. B, C, F, E. Remember, we have to name going around the figure. So B, C, F, E. B, C, F, E. And then the last lateral face is where this prism is actually sitting on, and that is A, C, F, D. Let's see, and these are rectangles, and they are the lateral faces. The places where those lateral faces intersect or meet. So this lateral face here and this one over here, they intersect right there. That's a lateral edge. On the diagram, that's this one right here. So BE is a lateral edge, as is segment AD, as is this one right down here, CF. So segment BE, segment AD, and segment CF are the lateral edges. The remaining 6 segments in there, so if we start right back here, segment AB, segment BC, and segment CA, they're kind of the sides of the base, if you will. Those are just edges. So segment AB, segment BC, and segment CA. And also this front, segment DE, segment EF, and segment DF. These are just plain old edges. They are edges because they connect a base and a lateral face. Okay, let's turn the page here. And we are going to talk about lateral surface area versus total surface area. Lateral surface area versus total surface area. Lateral surface area is the sum of the areas of the lateral faces. The lateral surface area is the sum of the areas of the lateral faces. Those lateral faces are the sides. Total surface area is the lateral area of the sides, plus the area of the two bases. Two bases, top and bottom. So total surface area is the area of all the faces. Now we can write the total surface area kind of as a formula if you want to. Think about it this way, is that it is the lateral area plus two bases. And we do use a capital B there, capital B, to represent the area of a base. All right, let's take a look at a few examples. We're going to go right here. We want to find the lateral surface area and the total surface area of this rectangular prism. Right there, rectangular tells you the shape of the base. Rectangular tells you that the shape of the base is a rectangle. And this one's actually kind of nice. It is sitting on its base. And again, I like to kind of identify where that base is. And I, again, like to use a colored pencil, and I darken the edges and then shade lightly in the middle. I think it makes the base stand out a little bit nicer, better. And then we can trace this top base. There's the bases. Okay, so we have length, width, and height. This is not length times width times height. That's volume of a rectangular prism, but we're not at that point. We're not doing volume now. I know some of you, when you see length, width, height, you just want to go length times width times height, but that's not the case here. Length is 12 centimeters, so 12 centimeters. Width, 7 centimeters. And the height, 3 centimeters. All right, to find the lateral area, let's think about the area of the 4 sides, or the 4 lateral faces. We have this left side, the back, this right side over here, and then the front, which is right there. And when you look at this, do you see that this front piece right here, oh, here's our rectangular prism sitting right there. So the front right up here, that's exactly the same size as the back piece, yes? Front, back are exactly the same, and they are rectangles as well. So we can say that we have the front and back. And I like to kind of draw these out so I can see them very individually. The front and the back, let's see, it's 12 across and 3 high, so 12 by 3. All right, we have 2 of those, so that area is going to be 2, and then the area of one rectangle, base times height, 2 of them, because we have the front and the back, so that's 2 times 12 times 3. I would do 2 times 3 is 6. 6 times 12, 72. Left and right. So here's the right piece over here. That right side, this one right here. And the left side over here. Again, the right side and the left side are exactly the same size. So, and they are both rectangles as well. Okay, so this piece right here, this is the rectangle we're looking at. And that is 7 by 3. 7 by 3. And we have 2 of those. So the area there is 2 times base height. 2 times 7 times 3. And again, I think I would go 2 times 3 is 6. 6 times 7, 42. So our lateral area is the front and the back sides, 72, plus the left and right sides, 42. And 72 and 42 is 114. This is area, so these are centimeters squared. There's that lateral area. Let's look at the total surface area. All right, total surface area here, just like we wrote up at the top. Surface area is lateral area plus 2 bases. All right, lateral area we just figured out was 114 plus those 2 bases. All right, the base is this right here, or you can look on the bottom. That's a rectangle. Its base is 12 times the height of that rectangle that's on the bottom. That's 7. So 2 times 12 times 7. Oops, I wrote 17. 2 times 12 times 7. 114 plus, let's see again, I think I'm probably going to do 2 times 7 is 14. 14 times 12, 168. And then 114 and 12, excuse me, 114 and 168, that is 282 centimeters squared. All right, let's take a look at one more. This last one for this weekend for you. Thank you so much for watching this. Okay, we want to find the lateral surface area and the total surface area for this right triangular prism. All right, now, right there in the title, right triangular prism, that is telling you the shape of the base. So, right now, this thing is not sitting on its base. The base is a right triangle. So look for a right triangle in there. There's one here. And there's one back here. There's the bases. Oops. Okay, this is this prism right here. You made this one on Friday. That's exactly what this one is. And it's sitting like that. So, can you see it? So I'm kind of holding it like this. But it's sitting on this edge, this face down here. It's sitting on one of the lateral faces. Okay, it's not sitting on its base. Sitting on its base would look like that because the triangles are the bases. All right, let's find the lateral surface area. And the total surface area. Okay, so this thing is sitting like this. All right, that we have to find the lateral faces. So here's a lateral face. Here's a lateral face. And then what it's sitting on the bottom is a lateral face. That bottom is not a base. So this right here is this lateral face back here. And it is a rectangle. I'm just going to call that one the left one. The left one is a rectangle. And when I look at the dimensions, I need this side. That's 3. And then we need this one. How long is that? That's 15. So I got 3 by 15. So that area is 45. We have the right face. So again, if this is sitting like this, here was the left face. Here's the right face right here. That's a rectangle. There's the right face. It is a rectangle. And it's right here in this one. Dimensions of that rectangle, 4 by 15. And 4 times 15, that area is 60. I've got to make this smaller so I can see the picture all at the same time that I write this. All right, and then the last lateral face that we have is actually the bottom piece down here, which is sitting on. And that bottom piece is another rectangle. Let's look at it in the diagram. Here's the bottom piece. What's the dimensions of that rectangle? Well, clearly, one dimension is 15. Okay? We need this dimension right here. That one's a little bit harder to find. So come back at this diagram. See this side up here is 4? So how long is this side right here? Yes, that's 4 as well. Oh, look at this. This is a right triangle now. a right triangle with a 3 and a 4 on the legs makes the hypotenuse. Yes, 5. There's the dimension of that bottom rectangle then. That's 5. This bottom rectangle, 5 by 15. 5 times 15 is 75. So our lateral surface area is 45 plus 60 plus 75. 45 and 60 is 105 plus 75 is 180. And these are centimeters squared. There's that lateral area. Okay, surface area. We are doing lateral area plus 2 bases. Lateral area we just figured out was 180 plus 2 bases. All right, what shape is the base? What shape is that base? It's a triangle. Formula for area of a triangle? 1/2 base times height. Look how pretty this is. 2 times 1/2? Gone. All right, now base and height of this triangle. Because it's a right triangle, don't use the 5 as the base. Kind of turn this triangle in your mind, if you will, and then the base is 3 and the height is 4. In a right triangle, the legs make up the base and the height. So 2 times 1/2 gone. This is 3 times 4. We have 180 plus 12, 192 centimeters squared. Okay, thank you very much. I will see you on Monday.